Hello, this is Mr. Stansbury. I'm going to take you through the notes on financial mathematics with a graphing calculator. We're going to use the TI-84 for all this. So with a TI-84, you should, at the end of this, be able to say, I can use the compound interest formula to calculate principal, interest rate, amount of interest, length of loan, and or effective rate of a loan. Okay? So, if you will remember, here's our compound interest formula. Now, there is this wonderful thing on the TI-84 where you would want to go into apps, finance, and then TVM solver, and we'll walk through several of these here. And once you do this, it gets you to this screen here, okay? And this screen here is going to represent all this information here on our compound interest formula, okay? So this N here is still the N, it's the number of years. This I% is the interest rate, or the R in this case. The PV is the present value, and you always want to put this in as a negative number. And the way I remember that is, like, normally you're investing money into a loan, so that you're actually giving away something. You're not giving away, but you're putting your money into an account, so you're actually taking it out of your, say, savings or something like that, so that you're actually subtracting money from your savings. So this PV is always negative. This PMT is the payments. We won't ever mess with that, so that's always going to be 0. FV is the future value. This PY, that's going to be payments that you're going to make per year. We're also going to leave that alone. We're always going to leave that as 1. And then the CY is the compound periods per year, which in this compound interest rate interest formula is K. Okay, so we're going to use all this lovely information here to solve all these problems on our graphing calculator. Okay, so let's take a look at example 12 that we looked at earlier. 22,000 invested for 8 years at 3.1% per annum. Interest compounded. Ooh, let's get rid of that. Let's see. Let's make this a little bit nicer. Hide the large display. There we go. Okay, so here's what your graphing calculator hope looks something like that. Okay, see, it was compounded annually. What will it amount to at the end of this period? Okay, so here's what we do. Our N. Here, let me do this first. Here's all of our lovely information here. Okay, so our N is simply this N here too. Oops, sorry, every time I do that it gets rid of my graphing calculator. Okay. So, sorry, N is our time, so it is 8 years, so we're going to put 8 in for this N. The I is the interest rate, 3.1. You do not have to turn it into a decimal, you just leave it as a percent. The PV, present value, remember this is always negative. Okay, so we're going to put in negative, and then you're investing 22,000. Oops, lost a 0 there. 22,000. Your payment you're always going to leave as 0. Future value is what we're going to calculate, so we just leave that alone. Doesn't matter if there's a number in there or not. PY, the payments per year, if you remember, we're just going to leave as 1. And then CY is the compound periods per year. So since it's compounded annually, we're going to leave that as 1. Okay. Once you have all your information in here, what you're going to do is you're going to go up to what we want to solve for. So we want to know what it's worth at the end of the period here. So we want to know what the future value is, right? So we're going to highlight that, and we're going to do alpha. And then this right down here is solve. You push that, and that's what it's going to be worth at the end, 28,086.14. So 28. I already forgot here. 08614. Okay, so that's going to be what A is here. Okay, how much interest has been earned? We'll simply just subtract 22,000 from that, and that'll give us 6,086.14. Okay, all right, let's look at some more examples. We're going to keep using the TVM solver. Okay, let's take a look at, this example here. Okay, so we got here example 13, 7,500 invested for 5 years at 3.5% interest, compounded quarterly. Find the investment at the end of the period. Okay, So we go up to, you like to start at the top. That is the time, right? N is time, so that is 5 years. Okay, and then we go to the interest rate, which is 3.5. Okay, and then what we invested, which is negative 7,500. So we invested 7,500. We had to take it out of our bank account, so we're actually giving up 7,500. That's why it's negative. Payment, we're going to leave alone. We're going to try to calculate what the future value is, so we can leave that alone. Payments per year is always 1. And then compound periods, it's quarterly, so this is going to turn into a 4. Okay? So then what we do is we go back. We're trying to figure out what the future value is, so we highlight that, push alpha, and then solve, which is enter. And that tells us it will be worth $8,927.55. Okay? All right, let's take a look at another example here. How much does Lionel need to invest now to get a maturing value of $17,000 in 3 years' time, given interest at 5.2 compounded monthly? Okay, so this 17, instead of going in for the present value, is going to go in for the future value. Okay, so that's pretty much about the only thing that's different. So number of years was 3. The interest rate is 5.2. Okay, present value, that's what we're going to figure out. Payment, we always leave as 0. Future value, we know it's going to end up at 17,000. Payments per year we leave alone, and it said that this was compounded monthly, so the CY is going to be 12. So now we go up to the PV to see how much we have to invest in order to end up with 17,000. So we do alpha solve, and we have to invest $14,549.41. Okay. All right, next example, example 17. Pair of horseshoes was originally purchased for $220. Depreciates by 40% each year. Find their value after 3 years. Okay, so back on our graphing calculator here. So the time in this thing here is going to be 3 years. Interest rate, it's depreciating by 40, so we're going to want to put negative 40 in there for our interest rate. Originally purchased for $220. So this is going to be negative $220. No payment. Future value is what we're going to figure out. So we leave that blank. And then the compound periods, depreciation. It doesn't say anything on there. Depreciation is always a yearly thing, at least for what we're dealing with. Okay, so now we're going to want to calculate our future value. So highlight that, alpha, solve, and those shoes are going to be worth $47.52 after 3 years. Okay, and to figure out how much is depreciated, you would simply subtract, take 220 minus 47.52, and that's how much money that those shoes lost or depreciated by over that time. Okay. Next one, we've got Pete. How long must Pete invest $2,200 at 3%, 3.7% compounded quarterly for it to amount to $3,500? So we bring this up here, and the how long is the n, so we're going to solve for that. And if you'll remember earlier, we had to do this with logarithms, so that this calculator bit is going to make this a bit easier. So investing 2,200, so that's negative 2,200. Oh, sorry, that's the interest rate. That would be bad. That is 3.7. And then the investment is negative 2,200. Payment we leave as 0. Future value, we want it to be 3,500. Payments per year is always 1, and then compound periods. I don't think it said anything about compounded quarterly. So the compounds per year is 4, and we want to solve for the time. So we highlight the time, the n, alpha, solve, and we get it's going to take 12.6 years. Right? So a little over 12 years, 6 months, so probably 12 years, 7 months, something like that. Okay? All right, and then one more example we have here is Amani deposits $12,000 in an account that compounds interest monthly. 5 years later, the account has a balance of $16,500. What annual rate of interest has been paid? Okay, so we clear this out, and it says 5 is our time. Let's see what interest has been has been paid. That's the interest. That's what we're going to solve for. So we can just leave that one alone for now. Invested originally negative 12. So we got 12,000. And then our payment is 0. And it ended up at 16,500. Payments per year was 0. Compounds monthly. So that CY is going to be 12. Okay, and then what we want to figure out is what was the interest rate. Highlight that. Alpha, solve, and the interest rate was about 6.39%. Okay. All right. That's how you do all this financial mathematics all on the graphing calculator. Okay. If you have any questions at all about this, please feel free to ask in class. Thanks.